7.5, dot product. We're going to find the dot product of two vectors and the angle between two vectors. Remember last section I gave you some definitions, what a vector was, how it's denoted, addition, subtraction, scalar multiplication. So this is from last section. For two vectors, v sub 1, comma v sub 2, and w sub 1, comma w sub 2, the dot product is defined as you take the first coordinates of your vector and multiply them plus the second coordinates of your and multiply them, and then take the sum. So if I want to find the dot product of these two, I take -1 times -3 plus -2 times -4. So 3 plus 8 is 11. You're done. Example 2. If the vector is 6i minus j and 2i plus 7j, remember this is really just the vector 6, -1, and 2, 7. So you take 6 times 2 and add it to -1 times 7. So 12 plus a -7 is 5, and you're done. The angle between two vectors, v and w, is defined as, here's the angle between them. If you take the dot product, it's equal to the magnitude of one vector times the magnitude of the other vector times the cosine of the angle between them. Okay? So if I want to find, given a magnitude of u of 3, a magnitude of the vector v of 4, and the angle between them is pi over 3, I want to find the dot product. Okay? And sometimes I might ask you to find the angle between them, so that'll be the only unknown. So plug in what you know. Magnitude is 3, this magnitude is 4, and this is pi over 3. So I plugged in what I knew. Cosine of pi over 3, remember pi over 3 triangle, if this is pi over 3, 1, 2, radical 3 is what the triangle looks like, so the cosine is 1/2. So 3 times 4 times 1/2, which gives you 6. Example 4, find the angle between the vectors. -2i plus 3j, and w, vector w is equal to -4i plus 6j. Again, the same formula. Remember, the dot product of the two vectors is equal to the magnitude of one times the magnitude of the other times the cosine of the angle in between them. So let's find the magnitudes. The magnitude of the first vector would be -2 squared plus 3 squared. So 4 plus 9 is 13, so it's the square root of 13. Magnitude of this one would be 16 plus 36. 16 plus 36 is 52. 16 plus 36, okay? If you need to see the workout, there it is, 52. And 52, you can think of it as 2 times 26, or 2 times 2 times 13. That's why it simplifies to 2 radical 13. So now I have the magnitudes for the formula. So I have that and that for the formula. Now let's find the dot product. The dot product, the first terms, -4 and a -2 are the first terms, so that's 8. 3 and 6 are the second terms, so that's 18. 18 plus 8 is 26. So now I have the dot product. So plug in what you know. 26 is equal to radical 13 times 2 radical 13 times cosine of theta. 26 is equal to radical 13 times radical 13 is 13 times 2 is 26. Divide by 26, I have 1 is equal to the cosine of theta. Remember, cosine is x over r. And x is 1 at 0 degrees. And you can put in your calculator too, the inverse cosine. I don't know if I'll let you use your calculators on this one, so make sure you know how to do it. I haven't decided on calculators yet for the test. Example 5. let W and V be two vectors in the plane with magnitudes of 4 and 5. So V and W are two vectors. V has a magnitude of 4. W has a magnitude of 5. The angle between V and W is 60 degrees. Find the magnitude of 2V minus W. Okay? So I can rewrite that as the dot products. Okay? That's what that is equal to. And I can distribute this. So 2V times that quantity and the negative W times that quantity. So there's what I did there. And then I have 2V times 2V. And then I have 2V times that W. So that's what I have there, or dot product of it. Same thing here. 2 times 2 is 4. So I have 4 and then the dot product here. I have 2 in the dot product. I have 2 in the dot product. And then I just have the dot product. Combine these two terms. Negative 2 and negative 4. Negative 2 is negative 4. The dot product of these two I can write as the magnitude squared. Magnitude of V, magnitude of W, cosine of theta. This is from the formula. The dot product is equal to the magnitude of one plus the magnitude of the other times the cosine of the angle between them. And the dot product of W and W is the magnitude squared. Now plug in what I know. So the magnitude of V was 4, so that's 4 squared. Magnitude of V is 4, magnitude of W is 5. The angle between them is 60 degrees. Magnitude of W is 5, so 5 squared. 4 squared is 16, times 4 is 64. Then I have 4 times 4 times 5. The cosine of 60 is equal to, something happened here. Cosine of 60, this is 60, that's 1, 2, radical 3. So that's a half, plus 25. Multiply that, that's 40. 64 minus 40 plus 25 is 49. Take the square root, and so you know that the magnitude of 2V minus W is 7, and you're done. Another way to do that same problem is if you want to memorize the magnitude of V plus W squared is equal to the magnitude of V squared plus the magnitude of W squared plus 2 times the magnitude of VW, or dot product of V and W. The subtraction, same thing, and then V plus W dot product of V minus W is equal to V squared, the magnitude of V squared. Magnitude of V squared minus the magnitude of W squared, okay? So let V and W be the two vectors again. So same exact problem. But now this time, I'm going to use the formula right here. The first one squared plus the second one squared, magnitude, plus 2 times the dot product of the two. So here's that squared, this one squared, minus 2 times the dot product. 2 squared I can bring out as 4. So I have 4 magnitude of V squared, magnitude of W squared. The 2 can come out, so I have negative 4 and then the dot product. Definition of this dot product is the magnitude of one plus the magnitude of the other times the cosine of the angle in between them. So here's a second way to do the exact same problem. So it comes out the exact same way. I don't care which way you do it. I just want to show you an alternative way. Okay? Same example almost as before, but now I want to find the angle between 2V minus W and W. Okay? So from the last example, we knew the magnitude of 2V minus W is 7. And it's given that the magnitude of W is 5. Okay? So the dot product of the two is equal to the magnitude of the 1 times the magnitude of the other times the cosine of the angle between them. That's what I want to find out, okay, that angle between them. Dot products here. I have 2v dot product of w minus w dot product of w. This dot product is defined as the magnitude of one plus the magnitude of the other times the cosine of the angle between those two, and that was 60. Minus, that's the magnitude squared. And then these I just left it the same. So now let's plug in what we know. 2, this right here, it's given as 4. This is given as 5. Cosine of 60 is a half. This would be 5 squared. This from the last problem is 7. This is given as 5. Cosine of theta. Theta is what we want to find. 2 times 4 times 5 times a half is 20. 5 squared is 25. 7 times 5 is 35. 20 minus 25 is negative 5, so negative 5 is equal to 35 cosine of theta. Divide by 35, so you have negative 1/7 is equal to cosine of theta, and then theta is equal to the inverse cosine of negative 1/7. On a test, you would be done if I said no calculators. Okay? If you want to find out what that angle is, just plug it in inverse cosine of negative 1/7 in your calculator and you get the angle. And that is an obtuse angle. From that equation, the dot product, if the dot product is greater than 0, it is an acute angle. If the dot product is less than 0, it'll be an obtuse angle, or it could be a straight angle, 180 degrees. If the dot product is 0, cosine of theta will be 0 in this formula. For this to be 0, that would have to be 0. Cosine of 0 is at 90 degrees. Okay? So the two vectors are perpendicular if and only if the dot product is equal to 0. So if this dot product is equal to 0, they're orthogonal or perpendicular. So now let's find out if these vectors are orthogonal. Take the dot product. First term's multiplied, second term's multiplied. That one is orthogonal. Next one, first term's multiplied plus the second term's multiplied. That's negative 24. That is not orthogonal. Okay? So there you are. And the homework for this section will be 1 through 6 all and 7 through 43 odd.